and those are equivalent. The regularization technique of mix-up, again, we're going to demonstrate this with images, but the idea is we can actually take multiple x's and combine them together. So let me give you an idea. Let's say we've got a happy face that doesn't happen to be centered. And we've got another image, which is a sad face. So this is a 1, and we'll call this one a 0, okay, because this is a happy face detector. And so this is x1, y1, we'll just use pink for it, x2, y. The idea is we could actually combine these to come up with some new instance that we use for training that is not a complete 1 or a 0. So we could, for instance, do a blend of these two. We could do, let's say, 30% of this and 70% of this. So we'll do a linear combination of these two, and those are going to be equal, something like this, where we've got a 70% of the happy face. That is, its intensity is 70%. Sorry, this one was the sad face here. My mistake. And 30% of a happy face. So it's kind of tough to tell with these, but this is 30% intensity and 70% intensity. So the pink one should be twice as intense as the sad face should be twice as intense as the happy face. And we would say this then is going to be a 30% of 1 plus 70% of 0. So the label on this, so this is going to be x prime, and y prime is going to be equal 30% of 1 plus 70% of 0, right? This label and this label. So we would try to be training use as our training instance the fact that this is a 0.3. So you don't have to say it is 100% certain or 0% certain it's a happy face. Here we'd say it's 30% certain it's a happy face. Okay. So we can do these both for transparencies, right? So if we look at pictures, we'll see part of one and kind of part of another here, and they don't have to be separated, right? It might very well be the fact that they're on top of each other. So we have, in another example, we might have sort of a ghostly happy face with, on top of it as well, a sad face. Right? And that's what would be learned here. We can do this mix-up both blending as well as by cutting. So let me use another example. So here we've got, let's say, a tree, and a separate training instance is a dog, whatever that thing is. And instead of taking all of this, but only take 50% of the intensity, and all of this, but only 50% of the intensity, or 70 and 30, we're going to just take, again, let's say 30% of this and 70% of this, but instead of intensity, we're going to do area. So 30% area, 70% area. So the 30% of area, what's 30%? 30% is a little more than a quarter. So let's say that's about 30%, maybe. Okay. So what would this equal? This would equal, in the bottom left would be this. So we would have something like that. And then in the remainder, we'd have this tree. So maybe that's what it is, okay? So that the tree is, right, because it's supposed to be this area over here. And we would say then Well, this is 30% the dog and 70% the tree. And that's what we would want this to learn, that it's 30% dog and 70% tree. Not that it is, if it's this training example, 100% dog or 100% tree, but some in between. So that's the idea of mix-up as a regularization technique. And this is a change to both x and to y. So this is the first example that we've seen where we're actually changing y's.